So we're going to be working on parallel circuits and going through an example. And just to remind you, a few tips for parallel circuits is that the voltage is the same at the beginning of each branch. The voltage is 0 at the end of the last branch. The current may be different in each branch, and the current before and after the battery is the sum of all the currents. And you have multiple resistors on the branch. The current is the same on the branch, but the voltage drops after each resistance. So those are a lot of things to remember. Let me show you an example which applies where all of these tips apply. So in your homework, you have problem number 6. So kind of let's work through problem number 6. I'm going to grab my pen. And what we're going to do is record some of the information we have. So we know that the total voltage drop is 30, that resistor 1 has 20 ohms, resistor 2 has 10 ohms of resistance, and that we have a current of 1 amp in resistor 3. So we're going to assume this is resistor 1, 2, and 3. So let's start with maybe filling out this first. Sometimes it's good to toggle back and forth. So I know that we have 30 voltage drop over the whole circuit. So that tells me that we started with 30 volts and we ended with 0 volts. So that means 30 volts are flowing through all along here. Now remember what I was saying in terms of tips for parallel circuits. Your volts, of course, are both 30 on both sides because they haven't gone through a resistor. So we keep the voltage the same in the beginning of each branch. If you look through here, you notice that there's only one resistor. That means that the voltage is going to drop all the way to 0, all right? Because it's using all that energy to power that resistor. So we have 0 going all the way through. We have no other resistors. For this one, though, you notice you have one resistor here and another resistor here. So the voltage drop is going to drop to 0 at the very bottom of this one. But it's not going to drop to 0 over here because you still have a resistor down here that's going to use some of that energy. So we have to distribute that energy from the charge. So how are we going to do that? Well, we know a couple of things. Let's work with what we have. So resistor 1 looks like it has a voltage drop from 30 to 0. So we can put 30 volts over here. And then if I do my math, 20, we do V equals IR. That's the equation I like to use. 20 times what equals 30, and it's 1.5 amps that do. So right over here, I can put 1.5 amps. All right. So now comes the next one. For the next one, that one is a little tricky, but do you notice that this is actually kind of like a series, right? So you have 2 resistors on one branch. So this is really a parallel circuit that contains a series within it. One of the things we know by series is that the current is the same at this branch. So you notice that the current flowing through here is 1. That means that the current flowing through here is 1 because it is 2 resistors on the same branch, okay? So if I know that, 10 times 1, this tells me that we have a voltage drop of 10. So take a look. 30 is what the voltage started with. It dropped 10, so that means it now is 20, okay? It didn't drop to 10, it dropped 10 to become 20. We know that there's 1 amp of current. And so now, with that said, I know that this one is 20. So what was the voltage drop here? This voltage drop here was 20. So what times 1 amp equals 20? It's going to be 20 ohms. Okay, next thing. What we're going to do is for current, we add up our current. So 1 plus 1 plus 1.5 works out to be 3 amps. To find resistance, that's the last step. What you're going to be doing is saying what times 3.5 equals 30. And in that case, I'm going to say, I have to do my math here. Hold on 1 second. So this, if I do my division correctly, this works out to be about 8.6 ohms of resistance. Okay? So now I have to draw my current, my circuit. So I have one battery and put a voltmeter over here. I have one resistor going across, voltmeter over here. I have two resistors over here with a voltmeter here for current reading. And one of the things I did not put up here is my total current is 3.5 amps. This one is 3.5 amps. So that's 3.5 over here, 3.5 over here, 1.5 amps here, 1 amp over here. So we'll label this as A, B, C1, D1. This is C1, C2, D2, E1, E2, and F2. So plotting this here, we do A, B, C, D, E, and F. A is 0 volts. B is 30 volts. C is 30 volts. And in this case, D drops down to 0 volts, and then for my red one, it continues at 0. So for my first branch, I have this voltage. Okay. For my second branch, I'm going to choose a different color. I'll use light blue. I have, in this case, 0, 30, 30, and now at level D, I have 20, which works out to be right here. And for E, I have still 20, and then it drops down to 1. So my voltage graph for the next branch would look like this. And that solves our problem.